Day 8, Car
And
Audio
welcome
School.
to day 8 of Car Audio School. This school is to teach you how to do your own install, become a technician to get a job at a shop, so you know what you're talking about, and or start your own shop, which is what I plan to do. This is my online resume, and this is for entertainment and educational purposes only. My goal is to help you do it yourself and keep you out of shops. You're going to learn how to do it yourself going through these classes. Yesterday we talked about AC and DC. So AC being alternating current. That is current that flows back and forth. And then you can think about that as a multi-lane highway or a multi-lane water system, because water has become a big theme. This seems to be the best way to explain water and street traffic. And then DC, being direct current, is a single lane highway where electricity can only travel down one path and only in one direction. So with that being said, now we're going to talk about grounding techniques, because think about leaving your home for the day and heading to the grocery store. And once you get to the grocery store, you pick up everything that you need. You can get back into your vehicle and return back home. So that's what the topic is going to be about today, the return path back home. And most, if not all the time, the only time I can think about it not being grounded back to the chassis. So the chassis is the metal frame of the vehicle. The battery, well, I'll finish the thought. The only time I can think of it not being grounded to the chassis is like on a boat. Now on a boat, it's all fiberglass or wood. There is no chassis or metal rail to return the electrical signal back to the battery. So on all vehicles, if you look at them, there is a power terminal and a negative terminal. And the negative terminal is usually grounded to the vehicle meaning chassis, or that's what they call chassis ground if you look at schematics, to tell you where the signal path is going. Now we're always going from negative to positive, even though the power goes, I'll say, from positive to negative. I'll say allegedly. So let's talk about grounding techniques. So what I want you to think about it as, think of electricity like it's taking a trip. It needs to get from the power source or the water pump, like the battery, to a device like your amp, and then back to the battery in a complete circuit. This provides a grounding path for it to travel. The second analogy I can give you is, imagine it like a water park. And all that water is literally moving in a circuit. Even when you get on the slide, you climb up the ladder, you get on the slide, water is being pumped up the slide and then back down the slide to, in this case, I'll say to provide lubrication so you don't get burnt on the way down. But so you can slide back down the slide and it gathers in a pool. So the slide, we'll call that the wire. It gathers back into a pool, the battery, and then that battery pumps the water right back up to the tower so you can go back down. This is similar to a engine block. So the water travels from the water pump, literal water pump, actually, this time on the vehicle, uh, into the engine block to cool it down, out of the engine block into the water hose, into the radiator to be cooled back down, well, through the thermostat. Mm, I said that wrong, but back into the water radiator to be cooled back down, back into the water hose that runs into a thermostat that when it heats up to a certain temperature, that thermostat will open up and let that cool water back into the engine block. It goes back into the water hose, or the water, we'll call it the water hose, the radiator hose, uh, to cool back down, to go back into the radiator hose, to sit at the thermostat to wait for the instruction to go back into the block to cool it. This is how your engine cools down. Although those are illustrations of how electricity needs to get back to the grounding point. Now, in a boat, you would literally run a very long cord. Now, practice is to make that grounding cable no longer than 18 inches, preferably about 12. The shorter, the better. But in a boat, there's literally no way for you to run the circuit back around, so you have to use a very long ground cable. So why is grounding, why is good grounding so important? Imagine trying to run with tangled shoelaces. It slows you down and can make you trip. I promise I can read. Similarly, a bad ground can cause all kinds of short problems in your car's electrical system, especially if you're adding new gadgets like amps and lights and speakers and everything that you can think of. Can cause your vehicle to have electrical issues, because all of these devices need good grounding points to make it back to the battery to circle back around. Some of these issues can be weak power, like a water hose with a kink in it. Not enough power can get to where it needs to get to. It can also cause annoying noises. So we talked about this, I believe, yesterday, maybe the day before. But the hum that comes from the alternator that manifests itself through the speakers, you can actually hear the stepping on the gas and the revving of the engine through the speakers that you installed. You may hear buzzing or whining in your speakers, kind of like static on a radio. This can happen if different parts of your system are trying to use different home bases or different grounding points. And this is called a ground loop. So what is a ground loop? I was going to talk about this tomorrow, but we got a couple of minutes, so I'll give it to you now. A ground loop is a closed conductive loop through the ground connections of an electrical device that can cause noise, hum, and interference in audio, video, and computer systems. So that's the definition of a ground loop. So it can also cause overheating and damage to your components. Components can get too hot and even break down if electricity does not have a good return path. Now, most of the time, if the gauge thickness of the power and or the ground is too small, wires will get hot. If the ground point, which is what you'll normally see, the ground point melted on the amplifier that's terminated to chassis. If that's not a good ground, or it'll wiggle, it'll spark, and or create excessive heat at the amp terminal point, and the amp where that gauge wire is plugged into, it'll melt that terminal, which can cause fire, and it's all bad from there. I'll just read it. So, what are some key grounding points to keep in mind? Number one, use the car's metal frame chassis as a good common ground. Think of the metal body as a superhighway, highway again, for electricity to go back to the battery. It's often the best path because it's very conductive. And if I had a visual, I would show you a literal metal frame that the car sits on top of. Some of these vehicles, you have to go to frame because the metal sheets that they press together is not a good path back to ground, because most of the time it's not a good path when they bolt it to the frame. Create a single home base. It says in the back, but for aftermarket stuff like amplifiers, it's usually best to ground them all to a single clean metal spot in the rear of your vehicle. This helps prevent those annoying ground loops. If one ground connection goes bad, they all might go bad, making it harder to find the problem. But here they're trying to say if you put them all to one spot and ground it, shave the metal away or shave the paint away, ground them all to one spot, it makes it easier to find where that ground loop could be coming from. But a lot of times, a lot of techs will ground it in multiple places, or if they have 2 amps, they'll ground one to this side of the vehicle and one to this side of the vehicle, and you can't really tell where the ground loop is coming from, or the hum or the hiss that you would hear in your stereo system. And then it says, don't run a huge ground wire all the way to the battery. The car's metal frame is generally better at conducting electricity than any wire you could run. Now, again, this is absolutely true, except for in the case of a marine application, and there is no rail, there is no unibody, there is no chassis to go back to the battery. And usually those batteries are in very, very, very awkward places, and you have no choice but to run all of your wire to where it needs to go. Small extensions are okay. If you have ground wires, if your ground wires are a little short to reach your single ground point, a small extension is generally fine. Depends on how you connect it. Usually they have couplers that look like distro blocks, and distro blocks are what turn single lane highways into multi-lane highways, or extend single lane highways. You can do it. I wouldn't. I would just get a longer ground, and or distro it to another amp where you can run a longer ground. It makes more sense, at least in my mind. Avoid factory ground spots. Be careful about the using of existing grounding points, especially if they are also used for things like light switches. Even in this case, I'll say reverse lights, because a lot of people like to get their ground and power from that reverse light. But that can cause interference, especially if it's a pulsing signal, but we'll talk about that later. I'm running kind of long today. And then test your grounds. Use your multimeter, a tool that measures electricity, your DMM, to check if you have a good ground connection. You can check for continuity. I'll show you how to do that, not tonight. When the power is off, or measure voltage drops, and those you can measure in between different points to make sure the voltage is the same and there's no drop. Conversation for another day. When the system is running. And then, in simple terms, good grounding is all about providing a clean, reliable, and common return path for electricity in your car's system. It helps your electronics work properly, prevents noise, and keeps things safe. A little long-winded today, but that is proper grounding techniques for, for your vehicle and boats. And I said vehicle, I meant car, but this is how you get power back to the battery. There has to be a good grounding point, highway, for that signal to go back to the battery, which is the storage, and a water pump, which is tied back to the alternator, which generates the electricity, which goes back into the vehicle to power all the devices to come back down this highway to get back to the battery, and that's how that happens. Tomorrow we will be back with a much shorter video. I'm going to start posting these on YouTube. Always tip your technicians, because they put in a lot of work to learn all of this information. Donate, because we're going to get it popping pretty soon. I personally need help getting Direct Tech, All Data, and Mitchell 1, and these are wiring diagrams, so I can aid you in finding where everything goes. And that's it for tonight. So appreciate you rocking with me. We'll be back tomorrow. Later.